Alright, so today we're going to be talking about the perpendicular bisectors and the angle bisectors, okay? Both the perpendicular bisector and the angle bisectors are concurrent, and they have special names, okay? So, let's go ahead and start with the perpendicular bisector. Now, remember, a perpendicular bisector, perpendicular means 90 degrees, and bisector means it cuts into two equal pieces, okay? So it cuts the side in half. Now you'll notice that a perpendicular bisector does not have to go through the vertex. In fact, this perpendicular bisector does not, okay? What is important is just that it cuts it in half and it makes a right angle. Now we can actually do perpendicular bisectors with our compass, okay? We have learned how to do that. So I might ask you to construct the perpendicular bisectors in a triangle. You need to be able to connect with your compass and with this, okay? Now the perpendicular bisectors are concurrent, and the point of concurrency is right here. We actually call this point of concurrency the circumcenter, okay? So if you'll take a look at this picture, we have three different triangles, acute, right, and obtuse, and they all show the perpendicular bisectors, okay? Now in an acute triangle, the circumcenter, okay, that's what we call the point of concurrency for the perpendicular bisectors. And you'll notice that the circumcenter is actually on the inside of an acute triangle. It is on the triangle itself in a right triangle, and it is outside of the triangle when it is obtuse. Okay, so you need to remember a couple of things. The perpendicular bisector makes a point called the circumcenter, and the circumcenter can be in different locations based on what type of triangle it is. Acute, it's inside. Right, it's on. Obtuse, it is outside. Okay? Now, the perpendicular bisectors of a triangle intersect at a point that is what we call equidistant from all the vertices. So, equidistant. So, that means that this point to the vertex A is congruent to the vertex B to P, and is congruent to the distance P to C. Now you'll notice that there's a circle drawn around here. What that means is that P is actually the center of the circle that is circumscribed around the triangle. Okay? That means that BP, AP, and PC are all radii, and we know that radii have to be of the same length. So now do you understand why the perpendicular bisectors create a circumcenter? Because that center is the center of a circle that is circumscribed around the triangle, meaning that it touches all four vertices and is equidistant from the circumcenter. Alright, so PA, PB, and PC must be all of equal length. Alright, so let's put that into motion. If the perpendicular bisectors of PQR meet at a point S, find PS and QS. Alright, now PS and QS need to be the same length as SR. They need to be equidistant from all the vertices. So if SR is 10, then PS and QS must also be 10. Alright, so here we have a word problem, and we're going to use the perpendicular bisectors in this word problem. It says, a company plans to build a distribution center that is convenient to three of its major clients. The planners start by roughly locating the three clients on a sketch and finding the circumcenter of the triangle formed. So they create a triangle to each client, EFG, and inside this they find the circumcenter. Okay? So, let's say the circumcenter, let's see, right angle, and it cuts it in half. That's not quite right, so let's continue. Oops. I'm not trying to move the picture, I'm trying to move the line. About right there. Alright, let's do another line. let's see, that's not quite a right angle, so there we go. And that looks to be approximately where it cuts it in half. And then we'll do another line. Right angle, cuts it in half. Alright, so they construct the perpendicular bisectors like that. So that means right here is the circumcenter. Now, it says make a sketch. Okay, so, I kind of jumped ahead there a little bit. My bad. Make a sketch of the triangle formed by the client and locate the circumcenter. Tell which segments are congruent. Alright, so what we need to do here is go ahead and connect the circumcenter to each vertex. So, I'm going to get a line, and I'm going to make it a different color. Let's make it green. So, connecting the circumcenter to each of the clients, or the vertices. And we know that those three lines must be the same length because the circumcenter is equidistant to all of the vertexes, or the vertices, excuse me. So, explain why using the circumcenter would be a good location. Basically, it's fair to everybody. This line, and this line are all the same length. Therefore, all clients have to drive the same distance to get to the distribution center. Alright? So, oh, hey, not bad. Look at this sketch as compared to mine. Not bad. Pretty close, not too far off, okay? But we could actually draw the perpendicular bisectors with our compass, okay? And then we would be precise. Alright, now let's talk about the angle bisector, okay? The angle bisector is exactly what it says. It cuts the angle in half, and it's something that you can construct with your compass. So you guys know, given an angle, how to bisect it. You draw your arc from these vertexes here, your intersection, connected to your vertex, right? So you can draw an angle bisector accurately with your compass and a straight edge. So that's what they've done here, and you'll notice that it intersected here at this point. That's called the incenter. Okay, so what we have here, before we go any farther with the incenter, is I want to tell you about this, okay? You know that the angle bisectors create an incenter. You know the medians make the centroid. Okay, you know the perpendicular bisectors make the circumcenter. And the altitudes make the orthocenter. Okay, so each one of these right here. Now, you can do your own memorizing technique. Okay, but I've come up with something that helps me remember it. I call this Aunt Betty makes peanut butter apples. Now, if you've never had peanut butter apples, I'm telling you, Granny Smith apples sliced up with creamy peanut butter. That's one of my favorite treats. Okay? So you could say Aunt Betty makes peanut butter apples. Okay, now I came up with something silly over here. I can carefully cook onions. Didn't know what else to say for O. So that's just something I've come up with. So when I'm writing this on a test or a quiz, to remember that, I just say Aunt Betty makes peanut butter apples. I can carefully cook onions. So this helps me remember. Now if you don't like mine, make your own, okay? If you just rather memorize straight up with flashcards, do it. You can use mine if you want to. If you don't, you don't have to, okay? But you now know all four centers and all four lines that make those centers, and you need to begin memorizing them because I will be asking you these, okay? All right. So now what is important about the incenter? Now notice in the circumcenter, the circle was outside of the triangle and touched all of the vertices. This time the circle is inside of the triangle. So if this is my center, then shouldn't P to F and D to P and P to E all be the same length because of the radii of a circle has to be the same length? Well, that's the case. The incenter is actually equidistant to all of the sides of the triangle. So that would mean that PD is congruent to PE and PF. Alright, so let's take a look. Here it says we have the angle bisectors and they meet at point H. Which segments are congruent? Now, looking at the circle, now I won't always be given the circle inside of the triangle, so you need to learn to not rely on that. All right, I have HN, HP, and HM because I know that from the incenter to all the opposite sides, they are congruent in length. So delete that. There we go. Alright, it says the angle bisectors of TUV meet at point W. Find the value of D. Now notice the circle's not given here, but I do know the incenter is made by the angle bisectors and is equidistant to all of the sides of the triangle. So I know that 2D plus 7 must be equal to 4D minus 1 because they are the same length. So then I'm going to solve for D. Let's go ahead and subtract 2D from both sides. 7 equals 2D minus 1. Okay, because 2D minus 2D is 0. 4D minus 2D is 2D. Oops, I didn't mean to cross that one out. Silly me. Alright, and then let's add 1 to both sides. So negative 1 plus 1 is 0. 2D equals 8. Divide by 8, D equals 4. Okay? Alright, so like I showed you before, this is my acronym. You can see in green where I've said Aunt Betty makes peanut butter apples, and then I can carefully cook onions. Those would translate. So if you take a look, peanut butter is PB, and so is perpendicular bisector. Okay, A for apples, A for altitudes, M for median, N for makes, Aunt Betty, angle bisector. Okay, do you see where I'm going with this? I, incenter, can, centroid, carefully cook, circumcenter, and then onions. Now the reason I have two C's here is because you have centroid and circumcenter. Sometimes it would be difficult to remember them, which C goes with which one. So I always did carefully cook, circumcenter. Okay? Like I said, you don't have to use mine, but it's just something I've come up with to help you. Feel free to make your own, whatever makes you happy. Alright, I will talk to you guys later.